You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Antithesis is an autonomous testing platform that finds the bugs in your software with perfect reproducibility to help you fix them. It supplements or replaces your existing testing tools and lives alongside your normal CI workflow.
Hello, and welcome to another episode of the New Stack Makers. I'm your host, Heather Joslin, Editor-in-Chief of the New Stack. Today we're coming to you from the exhibitor floor of KubeCon plus Cloud Native Con North America in beautiful Atlanta, Georgia. We're going to talk today about a widely used open source project at CT, which is, there have been some recent developments intended to make it more robust, and we're going to learn about those, and we're also going to talk about why more large, complex open source projects might benefit from better testing. Our guide for this discussion is Marek Siarkowicz.
Yeah, nice meeting you, Heather.
Nice to meet you too. He is a senior software engineer at Google and a lead maintainer on the project. Hi. Okay.
Glad to be here.
All right. It's morning here, as you can tell. Let's make sure our viewers understand, just so we're all on the same page, what is etcd and what does it do?
Yeah, sure. etcd is a distributed key value store. So it's already 12 years old, so that would make it older than the CNCF and the KubeCon's conference and Kubernetes itself. It was meant to have the same principle of Kubernetes. etcd is the source of truth of all things happening in the infrastructure. Kubernetes uses this as the brain because it was created with the same principle of having one source of truth of everything that happens, upgrades, downgrades, is coordinated in one place so that you don't lose knowledge what is happening, and you can make sure that you don't, your rolling update takes down everything in your infrastructure. It's done by one, and this is all stored. All the knowledge about what is intentional in the infrastructure is stored within etcd.
Yep. And how did your involvement with the project start?
Yeah, I had opportunity to switch teams at Google. I was working for 7 years on Kubernetes itself as one of the maintainers of metric server, and there was opportunity to change teams, and I always loved distributed systems. It was always too hard, too difficult to me, so I decided I want to go deeper, and etcd seemed as the most challenging thing around. So 4 years ago I decided to join to switch teams and join the etcd project at Google, and been maintaining etcd in GKE for 4 years.
So it was the challenge of it that appealed to you, the fact that it was there.
So outside of standard project, I know even Kubernetes, it has pretty simple rules of how you build the software. It's still the same flow, but when you so it's API server is just a layer that proxies requests web application to the storage. But storage itself, like etcd, is both needs to ensure that things are stored on the disk. It needs to coordinate between members, and it needs to upgrade, make sure that the state is properly maintained across upgrades, downgrades. Those are managing state here is the crucial part. And if you add distributed consensus like graph algorithm on top of that, it can get crazy.
Mm-hmm. Yeah. So there's a lot going on. What were some of the changes that have been made recently that have made it more robust? Is that an accurate description of what?
Yeah, we came up with the name robustness testing, which is I think something borrowed from other parts of engineering.
Uh-huh.
So we that would be 3 years ago. etcd project has hit some challenges related to reliability of the and correctness of the project. It took us 3 years to roll out to a new release, and during that time a lot of maintainers shifted and a lot of maintainers left the project and were replaced with new maintainers, and there was a drain of knowledge. So all the properties that could not be written into the code were lost with those people. So all the procedures, how to test, how to guarantee correctness, that was done before were not done for the new release. So we hit a project that we released a version that had multiple issues that were critical. Like if application crashed, it could cause an inconsistency. So like if you have 3 members as you normally run etcd cluster, that you expect all of them give the same request and response or respond same to a request, you could have one member to be go rogue and do something else and totally confuse all the higher level layers in Kubernetes. So we invested a lot into making it, preventing it from happening again by building our own a framework inspired by Jepsen to validate not only basic correctness but also correctness of distributed system, which is a level above. etcd provides you the highest guarantee of correctness from distributed systems, so-called linearizability. If you make it's basically you can have distributed system that should behave like a single node. So this is like a golden or grail of holy grail of distributed systems, and validating this is very hard problem. So we need to learn all this knowledge. We need to do our own failure injection mechanism. We needed to teach people, the community, how to debug it, and all those challenges were immense. We got from one problem to the other, how we can grow, how we can make sure that when current maintainers leave, how we can make sure that the new people will know what to do. So that's where we reached out to Antithesis, who were working on the deterministic simulation testing, which is an approach that allows you to make sure that even a distributed system that might seem chaotic and things that are happening are very hard to reproduce. Any issue that is sent by user, it's very hard to first thing you need to reproduce and prove that it's happening. Having that without deterministicity means you are throwing darts and trying to get lucky to find, you have some hypothesis, you try to reproduce it, but you're basically you need to get lucky to sometimes find the some race between multiple components or multiple logs and multiple separate processes communicating by network to find the bug. So this deterministic simulation testing allows you to linearize everything. So there will be only one execution path, and it always be reproducible. So that collaboration gave us ability to define the properties that were just in documentation or just in maintainers' heads, write them down as assertions, and assertions that were useful. So previously we already had assertions, but those were they never tripped. So it seemed if it never trips, it should be good. Yeah. But the problem is how they will trip, but the failure combination that you need to do to trip is very hard to implement yourself, and it's unique for every such property. So we solved the sharing knowledge challenge. We solved the reproduction of issues, and third, they provide us with testing or failure injection under tests, which we couldn't build on or we started building on our own. But it's PhD, reaching out to PhD level projects to students and asking how we can integrate with someone self-written Fuse file system that can simulate disk failure. So we needed to integrate everything on our own, but with this collaboration we just depend on the platform to do that for us.
Yeah, it does seem like, if they have it sounds almost like chaos engineering.
Yes, this is like chaos engineering, but in under one VM that makes sure that you can reproduce everything.
Mm-hmm.
So if you think about chaos engineering, it's like it does one action usually, like kills a process, kills an application, kills a pod or container, or does some network disruption. But it can do it it will do a one action and then need to wait for like system to reheal, because you cannot like take down 100% of your infrastructure at once. You need to make split it into actions. But in deterministic case, you can stack multiple failures, because like you are still not running on production. You are doing it like before you roll out your application. So by stacking the failures, you can find new paths that were never happen. So you instead of testing things that happen one per 1,000 hours or once in 1,000 chance, you increase it to 1 million. So you are getting more and more nines of availability.
Yeah, and if you're using it, if you're using etcd and an enterprise, it's scaling is important. Being able to scale that solution out.
Yes, yeah. We at GK we run a lot of etcd. I used to see one corruption once a year. So that's something that needed an expert knowledge, someone maintainer of the project to even understand what is happening and try to debug this, find the root cause, and bring it fixed to open source. And we've done it a couple of times, but it's better to shift left and have the all the knowledge, all the tools, all the simulate here, instead of doing running in production, having hours or years of running in production, do it in testing, simulate all the cases that might happen in the production in the future.
Yeah. So the results of that testing, you're being able to roll that out in the latest versions of etcd?
We did full retests. So for me, one of the main principles for our own and then later antithesis testing was we need to make sure that the system that we've built is able to reproduce all the historical things that we knew, that we all the lessons learned that we knew. So we started from reproducing all the historical issues. In both cases, they succeeded wonderfully, and we were then able to start testing the newest version. So if we know that we can if we know all the bugs that we had before, and we know that we can find, we have a trust that those parts of the code base are covered to that in future will not be. We have trust that we will catch it again and prevent a regression by contributors.
We promised at the top of this conversation we would also talk about open source projects more generally, and do you feel like most large, complex open source projects are being tested enough? And if so, if not, why not? What do you feel are some of the obstacles to that?
Yeah, my main challenge that I'm still having in the community is teaching people how to do this kind of tests, because this is outside of anything you could learn in university or in most companies. There are not a lot of companies that went so far to get to the same level. So it's beyond unit testing, end-to-end testing, or smoke testing. It's situation where you are trying to find 1 in a million failure, disk failure that results in your system one random node returning, something from 1 second instead of current state returning something from a couple of seconds ago, or things like that. So I think that there is a lot of challenge in sharing the knowledge. So I think we having. My hope is that with having the tools, the dashboards that are built by that are built just for that can help learn people this approach. And for open source projects, there is a lot of value for maintaining the core important parts that are usually open source project grow as a like tree, and there is a lot of at the beginning the main part is the most important, but as the project grows, there is more community. They build out like new features, new things, new CI/CD. So there is a lot of like people that can work on the leaves, but the core is usually very sensitive because it's connected to everything. So I think for project like etcd or Kubernetes, the core parts that I also like work on in both projects are not very accessible to most contributors. So having such approach to testing can allow maintainers to write rules that will ensure that even if maintainer is also a human, makes a mistake or doesn't have enough time to review something in full detail, will still be able to catch it in the testing, like even if the properties are very hard to define otherwise or might not been tested enough.
Is this more robust testing, is this possibly like a use case for AI? Is this something that AI could be involved in?
So there is an element of exploration. So if you think about traditional like execution of tests, you write a concrete scenario that goes through like A, B, C. So usually you have setup, all tests follow like setup, action, and then assertion. But this is like one scenario, and with those approaches, like robustness tests that we took, is we are changing it to be property testing. So you like can take encourage the program to take any possible path through all the things, and some paths include like failure. Some are requests, some are validating responses, some are failure injections. So AI would be interesting to use to make the exploration smarter. This is. So that we not only like cover the trivial cases or we stop hitting the same case, we can like explore, and then with this exploration we can find what things correlate, what not, what events correlate, what not, and this even goes to like granularity of code of line of code. So it would be interesting to see if you know how exactly code trigger a bug and what it correlates with the code. Can AI make even guesses where is the bug and be able to fix it itself, because we can pinpoint like exact lines of code that are needed to trigger the bug. So that's already a lot of data that for human is still hard to parse. So having more data here will like empower AI to give hints to the engineers or even fix the bugs themselves.
What's on the roadmap for etcd?
So we are trying to use the new build trust into the project to go back to the core, like the tree, to be able to add more features there. It's something that we haven't touched for a long time, but now we are pretty sure we can like start building new things, and we are talking about like building 2-node etcd clusters. So for anyone that runs Kubernetes, that's a big thing, that you need to run always when you run your control plane, you need to run 3 instances because for high availability you need to have consensus, which requires you to have reach majority. So you need odd number of nodes. But with so-called witness node, which can be a simple like even GCS bucket that only observes as a witness what is happening in the other nodes, we can go down to only 2 nodes. So we can save 33% of costs, and this is a huge change. It requires changes in consensus in all the state machines, all the layers. But if we don't, with like advanced testing and this, we can, instead of trying to add unit tests and hoping that we don't miss case, we can just write high-level assertions about the property that system maintains and just run it and see if it breaks. And if there is a disk failure, we will that impacts if the disk failure impacts the feature, we will see it like without like diving in on or making sure that we have 100% coverage, which is a myth that like 100% unit that's covered doesn't mean that your system can survive a network failure.
Okay. One last thing. How can someone get involved in the project?
So on our GitHub page, we have our contact information. So you can there is a link to our Slack channel on Kubernetes Slack. There is a mailing list link so that you can join, and if you join, you will get an invite to the meetings. So we have a bi-weekly community meeting for like the main community. We have a triage meeting, and we have even robustness tests. So we still share knowledge. If you want to join and see how we are debugging live some issues in distributed systems, that's the way to go.
Excellent. Well, that's a good place to wrap up. I just want to thank Marek Siarkowicz for joining us today. Thank you very much.
Thank you.
And I just want to thank all of you for joining our conversation. And this has been Heather Joslin for the New Stack Makers on the road at KubeCon in Atlanta. We'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.